Hello students, previously Form 3, Topic 2, Lesson 15, we have started gravimetric analysis. We have done example 1. So today, Lesson 16, we are going to do question 2. So to go to the question, we are told 1.0 gram of aluminum and copper were reacted with excess hydrochloric acid. If 840 centimeter cube of hydrogen gas at STB was produced, calculate the percentage of copper in the alloy. In bracket, we have the RM of aluminum to be 27, and we are told 1 mole of the gas at STB is equal to 22.4 decimeter cube. So this 1.0 is the mass of the aluminum and also copper in the alloy. And 840 centimeter cube of hydrogen gas, this is the volume of the hydrogen gas at STB. So we are going to start by getting the number of moles of the hydrogen gas at STB. But the volume that they have given us here is 840 centimeter cube, and here we are told 1 mole of the gas at STB is equal to 22.4 decimeter cube. So we have to make, first of all, equal unit or the same unit. So let us take this 22.4 decimeter cube into centimeter cube. How are we going to do that? By multiplying 1000 centimeter cube. So this one, we are going to get 22,400 centimeter cube, because 1 decimeter cube will be equal to 1000 centimeter cube. Okay, next, we are told 1 mole of the gas at STB is equal to 22,400 centimeter cube as the volume. So we are told, we can say, what about 840 centimeter cube as the volume of the hydrogen gas produced? So there, we can get the number of moles of hydrogen gas. So we are going to say 1 times 840 divided by 22,400 centimeter cube. This will be equal to 0.0375 moles of hydrogen gas. Moles of hydrogen gas. Okay, to check the question, we were having the alloy to contain aluminum and copper, and it has reacted with excess hydrochloric acid. So here, aluminum and copper, hydrochloric acid will only react with aluminum, because when aluminum reacts with the hydrochloric acid, we get aluminum chloride and also hydrogen gas. But copper is below hydrogen in the reactivity series, so that means it's not going to react with acid. Okay, there we are going to write the reaction. That's aluminum, metal or solid, reacting with the hydrochloric acid. That's HCl, which is aqueous. We are going to get aluminum chloride, aqueous, plus hydrogen gas. Balance, we put 2 in aluminum side, 6 in the side of hydrochloric acid. We put 2 in the side of aluminum chloride, and also 3 in the side of hydrogen gas. So here, we have to look for the moles of aluminum. So let's relate or get the mole ratio by having aluminum solid ratio hydrogen gas. So the mole ratio there is 2:3, because we have 2 in the side of aluminum and we're having 3 in the side of hydrogen gas. So we have gotten the number of moles of hydrogen gas as 0.0375 moles. So what about the moles of aluminum? So we are going to say 2 times 0.0375 divided by 3. So here we are going to get 0.025 moles of aluminum. Okay, we have gotten the number of moles of aluminum. Thereafter, we are supposed to look for the mass of aluminum. How are we going to get mass? The formula for calculating mass will be moles times molar mass. Moles times molar mass, or we can say moles times RM, because we are dealing with aluminum, which is an element. So in our case, the moles is 0.025 multiplied by 27 which is the molar mass of aluminum, there we are going to get 0.675 grams as the mass of aluminum. So remember, we are given the mass of the alloy to be 1.0. We are given 1.0. So, and the question, we are told calculate the percentage of copper in the alloy. So we have to get the mass of copper. Remember, we have gotten here 0.675 as the mass of aluminum. So we can get the mass of copper by just subtracting the total mass of the alloy minus the mass of the aluminum that we have gotten now. So mass of copper will be equal to 1.0, which is the mass of the alloy, minus 0.675, which is the mass of the aluminum. So we are going to get 0.325 grams as the mass of the copper. So if we want to get the percentage of copper in the alloy, percentage of copper in the alloy, we are supposed to take the formula as mass of copper metal divided by the mass of the alloy, mass of alloy multiplied by 100%. That's how we are going to use. So what is the mass of the copper? 0.325 divided by the mass of the alloy, which is 1.0 times 100%. So here we are going to get 32.5%. This is how we are going to get the mass of copper. Or else, what we are going to do is that we can use here the mass of aluminum, then we calculate the percentage of aluminum in the alloy, then to get the percentage of copper in the alloy, we take 100, then we subtract from the percentage of aluminum in the alloy. That one will still give you 32.5 as the mass of or the percentage of the copper in the alloy. That's the end.